Good morning, scholars, and welcome again to another day of math. So our focus today is going to be adding mixed numbers and a fraction, right? And so the first thing I want you to do is look at the problem that we are being asked to solve. The problem says 5 2/4 plus 3/4, and we're solving for the sum. And so when I look at this problem, I think to myself, well, wait a minute, just so that we clarify, we have a clear understanding. Which of these numbers is the mixed number and which of these numbers is the fraction, okay? And so you said 5 2/4 is a mixed number. You were correct. Why do you think that is? Because it's greater than a whole. That is correct, okay? And then 3/4, is that a fraction that's greater than a whole or less than a whole? And so it's less than a whole. And so our objective today is to combine these two fractions by adding them. We want to figure out what the sum is going to be. Okay, let's get started. Today's lesson, in my opinion, should be very easy to follow, and I feel like I can take my time with it, which is always beautiful. Alrighty. So the first thing we want to do, honestly, is because our denominators are the same, this is going to be super straightforward. And all we're doing is we're pretty much rewriting the fraction as a sum. So what happens when we rewrite the fraction? Well, I'm going to bring over the whole number, 5. Because 3/4 is not a mixed number, there is no wholes, I'm going to rewrite the 5 as is. And then I'm going to add the fraction parts. I'm going to think to myself, well, 2 plus 3 equals, on the sound of my snap, 5. And then, if you remember from our work with fractions this unit, we don't need to add the denominators because truthfully, this is only telling me what a whole is broken up into. And so it's not necessary to add denominators, and I'm just going to bring it over as is. Now, friends, this is a part where I think to myself, well, remember that when we are representing our sum, we want to make sure that our mixed number doesn't have a fraction that is greater than a whole. And I know this is a fraction greater than a whole because the numerator is greater than the denominator. And so we want to rewrite this fraction, and that's where we're going to be decomposing the addend, that is a fraction, right, to make the next whole number. And so notice here, if I have 5 3/4, I'm going to be decomposing my 5/4 to make the next whole number. Okay, I'm going to set this up using a number bond. I'm going to be decomposing this. And I'm going to think to myself, well, how do I rewrite 5/4 to have a whole and then sum? And I think to myself, well, I know I can rewrite a whole by always placing the numerator as the same amount as the denominator, the same number, I should say. And so because this is fourths, I can represent one whole by saying 4 4/4. But then that leaves me, well, 4/4 plus what gives me 5/4? And so 4 plus 1 equals 5. So I would rewrite that as 1/4. Okay? Next, now that I have my answer, 4/4 is the same thing as 1 whole. And so that is exactly what I'm going to do, is I rewrite the sum as a mixed number. And so I'm going to add my whole plus my other whole, right? We said 4/4 is the same thing as 1 whole. And that gives me 6 wholes. 5 plus 1 is 6. And then I'm just going to be adding the remaining fraction, which is necessary, right? It's not just 6, it's 6 1/4. Now, friends, if you are a visual learner like myself, I kind of like to see it drawn out as well. And the way I do this is I simply represent it using various tape diagrams. The first thing I'm going to do is I'm going to draw my first addend, my mixed number. And I'm going to draw this by, if I have 5 wholes, right? We know we have 5 wholes. 3, 4, and 5, and they're entire. So like truthfully, they're all shaded in because it's 5 holes. But it's not just 5 holes. Our mixed number tells us it's 5 2/4. So what I want to do is I want to draw a tape diagram. Okay. How many parts do you think we might partition this tape diagram into to show 2/4? Okay. Now, if you said 4, ding, 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 you got it. Yep. The denominator always tells me how many equal parts there are or how many equal parts there are in a whole. However, it seems that there's only 2/4, so I'm just going to be shading in 2/4, okay? Now that I have 5 2/4 represented, I now want to put together my second add-in, my fraction add-in, okay? To make the next whole number. So this is where I'm referring to my criteria for success. My next whole number would be, well, think about it. If I have 5, my next whole number would be 6. So how is it that I piece together 3/4 to create a whole? What do you think? Let me switch my markers so that we can see it a little clearer. Okay, well, I know 3/4, right? If I were to show 3/4 onto this tape diagram, I would only be able to fit 2 more fourths to create the whole. What do you think we might have to do next? Okay, think to yourself. Remember, I have to add 3/4 to my tape diagram. And so, we're going to have to show another whole, right? We're going to we're going to add the remaining fraction, if necessary, by partitioning our next whole into fourths and bringing over. Remember, it was 1/4, 2/4, but it's 3/4 that I need to add. Now ask yourself, what is our visual representation showing us? Well, it's showing us that we have 1 hole, 2 holes, 3 holes, 4 holes, 5 holes, 6 holes, and wait a minute, 6 1/4, which is the same answer we had using our number bonds, okay? Now, I hope that was pretty clear. However, if you need a little more practice, totally okay. I do want to show you this using another problem, okay? So stay tuned.